Hello, everybody. Thank you for joining today. Good afternoon. My name is Tim Huke. I'm the Chief Sales Officer here at Cedargate. I oversee our self-funded employer reporting and commercial ASO markets and strategies here at Cedargate, which include direct employer clients, TPAs, brokers, consultants, stop-loss carriers, and the like. That book of business currently comprises over 80,000 self-funded employers that are using our analytics applications, totaling over 22 million members across the United States. Thank you so much for taking time out of your busy schedules and joining us today for our session on AI, which is a really hot and relevant topic. The market is moving fast and furious with AI developments, and so we really feel it's important to take a step back and try to better understand and articulate AI's use and place within the healthcare ecosystem and landscape, how it's used in analytics, and how our self-funded employer clients and their advisors can use this new and emerging technology and use it in a responsible way to ultimately improve health and productivity, reduce cost, ultimately drive better outcomes for everyone. I mean, that is the goal here, right? So the question is, does emerging AI have the potential to fulfill that promise? We at Cedargate obviously think that it does, if done the right and responsible way. Again, thank you for joining. I am joined today by two of my colleagues that are a heck of a lot smarter and well-informed than I am when it comes to all things data science, AI, machine learning, deep learning, predictive modeling related. I'm joined by Raj Mahali, who is our Chief Product Officer at Cedargate, and Amy Wilson, who heads up our analytics efforts at Cedargate. Raj actually steers and oversees our overall product roadmap and vision at Cedargate, which not only includes our healthcare benefit analytics employer reporting application, but also includes our value-based care analytics application, which includes bundles and episode modeling, provider performance reporting. And these solutions can also help employers build high-performance narrow network solutions and help with steerage to high-performing providers. Amy actually oversees our data science team, which is responsible for our internally derived and proprietary AI and machine learning and predictive models. We are delighted to be joined by them today. I will quickly go over the agenda and then we'll get started. As far as the agenda goes, I'm actually going to play the role of MC, and Raj and Amy are going to tackle most of the meaningful content. We're going to break up the presentation really into four main categories. Part one, I think it's important that we take a step back and really define what AI means. We all are hearing a lot about AI, not only in healthcare, but in literally almost every facet of our lives in general. I mean, Apple just announced yesterday that they're going to be pushing their new Apple Intelligence AI enhancement with their latest iOS upgrade. So before we dive deep into self-funded employer challenges and how AI can help you guys, we really just want to level set and take a few minutes. We hear a lot of these different buzzwords and terms, whether it's AI or machine learning or deep learning or predictive modeling. So we're going to level set on that. Once we've done that, Raj and I are going to play off each other a little bit, and we're going to go through four real-world use case scenarios on how AI models and some of the models that we're deploying and developing here at Cedargate can help address specific employer challenges. I'll describe the challenge, and then Raj is going to describe what Cedargate's deploying and how we might help our clients, brokers, and advisors through the use of these technologies. After we do that, we're going to turn it over to Amy, and she's going to spend a few minutes describing how Cedargate's data science team builds our predictive models, but not only how we build them, how we continue to test them, ongoing development and deployment, and then how we train our models to improve over time to ensure that they're highly accurate and have a true positive rate for our clients that are using them. When we're done with that, we're going to wrap up and turn it back over to Raj, and he's going to talk a little bit about data security and responsibility and ethical AI development, and then we'll wrap up. So the last thing is I'll be monitoring questions in the chat. Go ahead and ask questions. If we don't get to your questions, We will copy those questions after the session, and we'll answer those and share those back with Employee Benefit News, and they can distribute them to the attendees and participants. So without further ado, let me turn it over to Raj, and we'll just lay the foundation with AI definitions. Raj?
Thanks so much, Tim. As Tim alluded to, I know it can be confusing. We have a lot of different terms out there for artificial intelligence, machine learning, and deep learning, generative AI. So I just wanted a level set, and I hope the slide is a little bit grounding. When we talk about artificial intelligence, it actually encompasses all of these categories. Artificial intelligence is really the science about using large amounts of data to create better predictive analytics, and also to leverage that type of data to produce new analytics in the form of generative AI. So what is the difference between AI and machine learning and deep learning? With machine learning and deep learning, you're typically taking large amounts of data sets and looking at different relationships. These data sets are so large that it becomes difficult for humans to create and understand the patterns. So through machine learning, you can actually leverage the power of these algorithms to produce better predictive analytics, to identify members early or patients early for intervention. And those are the traditional kind of analytics that we've seen. Now with generative AI, it's really about taking that to the next level and creating new insights off of prompts. So you might be familiar with tools like ChatGPT or DALL-E. ChatGPT, for example, you can engage with it almost like it's a human. You can ask it to write a poem. You can ask it to make that poem funnier or sillier. It's generating new content, new information from you, and it feels like a real human is doing that. DALL-E is an image creator where you can actually describe an image you want, and it'll render it for you. And it's really these exciting tools that are now enabling us to create better predictions, but also to supplement a human and make us even more productive. I think there's going to be a lot of use cases, and we'll go through a couple of them. In healthcare, you got to be a little bit careful with those use cases, but I'm excited to talk with you about them today. So I'm going to turn it back over to Tim, where we'll start a dialogue about how you leverage some of these tools and these examples in the self-funded space. Tim, why don't you take it over?
Yeah, great. Thanks, Raj. Okay, so we're going to move into phase two, which is really trying to land on a few real life scenarios and how AI and these models can be applied to some of the challenges that you're all facing out there in the self-funded employer world. We're going to go through 4 challenges: proactive chronic disease management, high cost claimants, preventable utilization, and enterprise efficiency. So on the first challenge around proactive chronic disease management, too often interventions come far too late and well after someone is already diagnosed with a chronic disease or multiple chronic conditions. Obviously, we all know that can result in higher costs, lower quality of life. From an employer perspective, it can lead to lower work productivity, absenteeism, poor health and outcomes, et cetera. So the challenge really is, how can we proactively identify potential chronic disease, ideally before someone's diagnosed with a chronic condition or disease, and using AI to get ahead of it, intervene sooner, which can lead to improved patient quality of life. I get this question a lot from a lot of our broker clients, especially with the recent rise of point solution vendors. Over the last 3 to 4 years, employers, brokers, consultants, payers, they're all getting inundated with point solution offers. I think it's safe to say that the market is collectively suffering from a little bit of point solution fatigue. They all come with the promise of lower cost and improved outcomes for your members. But unfortunately, we can't engage in all of them. So we're challenged with trying to make informed decisions on which ones to invest in, which ones will yield the best performance and ROI. And that all starts with data and targeting the right individuals with the right offers at the right time. And the sooner we can get ahead of who those individuals are before chronic disease hits, the better. So those are some of my background comments. I'll turn it over to Raj to talk about this particular challenge.
Sure. And, healthcare in some ways is backwards, where many times we're looking at a patient or a member or an employee after they've had emerged with a condition, and we're figuring out how to treat them. Proactive care and leveraging AI, today with the technology we have, we can finally maybe be a little bit more proactive, prevent folks from having onset of a condition, identifying patients, employees, members that have a condition, but we don't know about it. We're not pointing our tactics to them. We're not pointing care management or point solutions to them. If we take diabetes as an example, 1 in 5 people have diabetes, 8.5 million people don't even know they have the condition. The cost of a diabetic member can be $16,000 per year, with 10,000 being attributed to diabetes. That's 2.3 times the average cost per patient. What if you could identify the patient who is emerging to have diabetes, or that has no evidence in the data set you have that they have diabetes? You don't know they exist. You can't point Livongo to them. You can't point solutions. You can't engage care management. Your actuaries don't know that they have this condition. If you can identify them proactively, you have a much better ability to manage and to plan around that. So that's what we do with our predictive models. We have 25 AI predictive analytic models. Some of them are targeting towards patient populations, where we are predicting the onset of coronary conditions, COPD, and diabetes. And in the future slides, we'll talk about predicting sentinel events. We even predict models on will a patient, an employee actually be likely to take action? Will they have a diabetic foot exam, for example? So not only are they likely to have a condition, but are they likely to act and really take care of that condition? Using these models, self-funded entities can be more proactive on how they engage certain patient populations. They can deploy the point solutions that Tim talked about more effectively on the members. They can target interventions to the right members to really get the value of these investments. And that's really what AI is kind of offering. We run these AI models, and this spans across the next use cases that I'm going to tell you, but I'm going to tell you up front, across our 16 million book of business data set. That's our proprietary data set where we can really understand the patterns, and we can develop algorithms that are unique. They say good AI algorithms or algorithms cannot be produced without good data. And that's what we have in this book of business data set, a robust data set that spans the nation that allows us to develop these. And to evaluate the effectiveness of these models, we do use something called a Matthews correlation. What is a Matthews correlation, or MCC score, as you might hear? It's between -1 and 1, and the closer you are to 1 indicates that you have more positive correlation or more predictive power. For these diabetes algorithms, we were 0.8 or like 80%, so it's highly predictive. So it's indicating our ability to correctly predict the risk of having diabetes, the risk of onset of a coronary condition, the risk of a patient emerging to have these conditions, or it's not in the data set. And if you can proactively manage them, you can actually, get a lot of value in terms of reducing cost, improving quality, and helping those patients, those members, those employees really achieve their primary objective, which is better health. And you can do that more efficiently with higher accuracy and to deploy those resources better. So that's the power in this particular use case. Tim, do you want to get to the next one?
Sure. Thanks, Raj. So the next use case is high-cost claimants. And, we have a standard high-cost claimant report in our application. We actually have over 100 standard reports and dashboards that come out of the box. I can tell you that it's probably no surprise the high-cost claimant report or we have a separate shock claimant report are two of the most popular. It doesn't matter if it's one of our TPA clients or health plan or carrier clients or stop loss or our broker advisors or direct employers. Those two reports are always in our top 5 that are run. And there's a reason for that. Number one, the integration and reporting to stop loss is really important for self-funded employers. But also, we all know that it's, the old 80-20 or even 90-10 rule. It's 10% of the employees or patients that represent 80-90% of the cost. So identifying who those individuals are that are driving costs is important, but it's retrospective if you've already looked at the current plan year. So the idea here is to utilize AI and machine learning to predict future high cost claimants. And then if you can do that, try to get ahead of the curve and deploy education interventions, things of that nature to try to change behavior before it's too late. So I will turn it over to Raj to talk a little bit more about that.
Yeah, high cost claimants, they are select populations that could be driving a lot of your costs. And it's important through retrospective, looking back at the claims to identify those members. But we also have algorithms leveraging our book of business benchmark that predict, is this member predicted to have continuing high costs? So that can be important because it can help you identify the employees that are predicted to continue to be high cost. We put financial metrics to that, including PMPM, average paid, the expected cost. So you can compare that to your population. We can drill down into understanding the demographics of those high costs or predicted high cost members. We can even understand what places of service or what diagnoses are driving those populations, and even forecast those high cost claimants. Why is this important? Because clients can use this information to tailor benefit designs into the future to address these populations. They can leverage the information for their actuaries to produce better forecasts and analytics on that. They can also, if you have wellness programs, point solutions, or care management capabilities, provide this list of patients or members to those entities so you can proactively manage it. These are all tools that we have in the software and also have clients kind of using. So one way we've used this big data and AI to help with addressing these populations. Why don't you take it from there, Tim?
Thanks. All right. So we've got 4 of these real life use cases. We're on to number 3, which is preventable utilization. Similar to chronic conditions and high cost members, can you use AI to predict future state high utilizers? And what I would say here is, we're all in this era of digital health solutions, virtual health solutions. Telehealth is here, and certainly the pandemic accelerated wide adoption and acceptance of these technologies. But with that said, there still are concerns about high utilizers, overutilizers, unnecessary services, whether unnecessary ER and urgent care. The promise of digital health solutions and telehealth haven't totally curbed that. They've taken a little bit of a chunk out of it, but we're still seeing overutilization, whether it's ER, urgent care, unnecessary admits, readmissions, other areas of high utilization. So the challenge is similar. Can we try to predict who those high utilizers are going to be in the future and then target them with incentives in their interventions, educational content?
Yeah. Yes, Tim, this is an important one. You have these high cost events, these hospitalizations, ED visits that really can drive a lot of costs. So, if you can use AI or machine learning algorithms to identify those patients, those members that might be more at risk of having these types of events, you have an opportunity to get them on the right care plan and get them on the right course so they can reduce these events, or educate them about a place of service that might be better for them, or even a telehealth opportunity. We do identify patients that have high risk of hospitalizations, ED visits, and as an example, a patient that might have COPD or might have a respiratory condition that continues to use the emergency department. We can proactively identify those members and target them for a respiratory care program that might have them leverage services that keeps them out of the high cost and honestly, from a patient perspective, probably a poor experience, right? And connect them to programs that you might have that can really keep them out of the hospital, out of the admission, so they can have better care and really more efficient, high quality care. We also have algorithms and clients whose members might have back pain and might be continuing to go into the emergency department or leverage services for those types of conditions. If you can identify those members a little bit earlier and connect them to some of the point solution vendors out there that might be able to advocate for conservative care treatment and get them on the right course, services they might not be aware of, then you can keep them out of maybe some high cost, poor outcome surgeries. So really about identifying those members who are, might not be obvious in the data when you look at it retrospectively, but when we look at our book of business and we look at everything from their claims, their demographics, kind of other aspects about them from a SDOH perspective, we can really, maybe identify targeted populations where we can intervene and hopefully avoid these high cost events and produce better outcomes for those patients. This can help not only with the high cost events, but also absenteeism, presenteeism, to get them back to work, get them feeling great so they can be more productive for your organizations.
Great, thanks, Raj. So we're going to wrap up here. There's one more. We're referring to this as enterprise efficiency. Really, that is to say, how can we do all this, identify these actionable insights and more, and do it in an efficient, automated manner? Generative AI can certainly be deployed and help accelerate this process, turning learnings and insights into action. And this is exactly what Cedargate is working on. This is what Raj is working on with some of our future state roadmap items in 2025 and beyond. So we'll talk a little bit about that.
Thanks, Tim. We talked about prediction in the past vignettes, but I really do think AI has the potential, and generative AI, to supplement humans. And I emphasize supplement because I think in healthcare, the cost of poor information, inaccurate, it's not good enough to be X% correct. We really need to feel good about the analytics. They need to be traceable and interpretable so that we feel confident in them, and the stakes are much higher in healthcare. So we are really looking to produce a secure and accurate technology stack that supports these use cases to supplement the human so that they can make better decisions, be more productive, and identify insights faster, automatically, make that outreach, reduce the administrative costs from intervening even lower, and doing that in a way that our clients are comfortable with. What I want to emphasize is that our data, the information that go into these models will never be shared with any of the foundational models, with any of the models that these are being run on. And all the data, the prompts, the models, the fine tuning are all isolated by customers, so they're not commingled. That was a key in when we designed, working through all this, because we wanted security to be the utmost importance. And I think what's important is once you have this stack, we're going to be able to tap into it and leverage it for clients that are interested to help them produce better predictive analytics, but also there's going to be use cases that promote efficiency within Cedargate to, make us better at, for example, in our processes, like offer better, more accurate, faster, cheaper data onboarding and refreshes. So from an internal perspective, they will help promote efficiencies within our company, but also help promote efficiencies, hopefully, within our clients who would like to tap into these. So this is just how we're thinking about promoting efficiency across the client base to speed action to insight, but also within our own company to help offer services with better quality, more efficiently, and more accurately for our client base.
Thanks, Raj. I was trying to I was trying to do two things at once and respond in the chat, but I think I'll have to do most of it afterwards. Okay. So
And I can take
this
this one. So this is really going to allow us to unlock better predictions for our clients, next best action type analytics. When you're looking into a dashboard or a data set, maybe suggesting automatic insights out of it, making that easier, because right now it can be difficult. So we are playing with proof of concepts there. The key thing is we want to be secure. We want to know that the results are not hallucinations, et cetera. We want to make sure that the results that are being put out there have opportunity to look into the model to say what's driving it. And we know that states are looking at that as well. There's regulations at the state level that need insights that are being driven at the patient level to be explained. So that's how we're thinking about it. And that's being emphasized across the team that Amy leads, because culturally, we know that this is more than just data. These are real people, real providers, and the insights we generate cannot be delivered cavalierly. We have to make sure they're accurate. So it's going to unlock better predictions. It's going to unlock some applications that we're going to be conservative on that can be applied using these tools that can make us more productive. And it is going to help us from a Cedar Gate perspective get better quality information to our clients and allow our clients to leverage that information even more efficiently. So we enable them to tap into these resources. Our goal is to be that enterprise platform that our clients can grow with and can take advantage of these tools and are always on that cutting edge. But we also want to do that very securely and conservatively. But I'm excited about the future and would love to, partner with many of you out there to kind of, think about some of these to see how we can make best value of it. If you go to the next slide, Tim, I think this is where you're going to talk a little bit about our thought leadership before we go to Amy.
Yeah, I mean, the point of this slide is really just to note, I don't want to spend too much time on it. It's obvious by us hosting this webinar that we are a market leader in this space. We want to continue to drive thought leadership, and we're wholly committed to being a thought leader in this particular space for our clients and stakeholders. And these are just a few examples. They're quotes not just from myself and Raj in industry publications, but David Morris, our chief commercial officer, who I report to. And this is an initiative from Dave Snow, our CEO, down, that we are going to continue to develop AI, develop additional machine learning models that our clients can take advantage of, and we're going to continue to be a real player and thought leader in this space. Raj, did you have anything else to add? I mean, you run the product team.
No, I completely agree with you. It's something that we look forward to partnering, with clients, and really the objective is to adopt the technologies that help deliver the insights and the actions more efficiently to our client base. So look forward to continuing to develop them.
Yeah, I mean, the market is moving so quickly as it relates to AI. We want to continue to be on the cutting edge. Raj and his team, as well as Amy, we're an iterative software company. Every month we have new sprint releases of our software, and we continue to advance new models within AI that our clients are benefiting from and being able to take advantage of. And we're just going to continue to do that. At this point in the presentation, we're just going to transition over to Amy Wilson. She's going to talk about our AI predictive model development process. Amy, over to you.
Thanks, Tim and Raj. I'm happy to be here to spend the next few minutes talking to you more about looking under the hood. Tim and Raj alluded to some of our predictive model capabilities, and I'd like to give you a little bit more background about the work that it takes to deliver that capability. So let's start with talking about how much data we have to work with. We have, in our book of business database that's available for our ML team, we have 15 million lives, and we keep 24 months of history in that database, and we update it twice a year. So that means every 6 months, we're bringing in the most recent 6 months of data and dropping the oldest 6 months of data. And the data that we're talking about is eligibility, medical, and pharmacy claims for the most part, but we also include in that book of business our proprietary enrichments, and those include things like defining utilization events such as office visits, ED visits, hospitalizations. We have over 100 proprietary quality measures that we evaluate on every eligible member in the book, and those quality measures are things like compliance with preventive care guidelines like getting a mammogram, or for example, for a member with diabetes, making sure they get a retinal exam every year. And we also have chronic condition logic. So we're combing through our members' claims and identifying those that have chronic conditions and flagging them. So we use that data to create predictive models. Right now we have over 20 models in our application, and they can kind of be categorized into 5 different buckets. So Raj and Tim already alluded to some capabilities we have around chronic conditions. We have a set of models that are predicting members who are not currently diagnosed with COPD, heart failure, CAD, or diabetes, but are likely to be diagnosed with one of those conditions in the next 4 years. We have a set of pharmacy models, which are primarily around medication adherence, especially for members who are newly prescribed a medication. We have several models that are around compliance with quality metrics. So I alluded to, we have actual quality metrics in the application, but we're also predicting which members are likely to meet that quality metric in the next year. So how many among our members with diabetes, how many are likely to get an eye exam in the next year? We have a handful of models around risk analysis. Raj alluded to one of our most recently developed models, which is for members who are currently high cost, high need. How many of them will continue to be high cost, high need in the coming year? And the 5th bucket is utilization. So we all know that ED visits, hospitalizations, readmissions are events we'd like to avoid because they're costly, and we can use predictive models to see which members are at risk for each of these. And then the sixth bucket is in orange because it's sort of an unnamed bucket, but one of the most important, and that is the process of maintaining models. We can't just build something, put it in our application, and forget about it and move on to the next thing. It's a continual process of monitoring performance. I talked about how we're doing a book of business refresh every 6 months, and we take those refreshes as opportunities to assess the ongoing performance of our models. When data changes, as healthcare trends change, the model performance could degrade, and we might need to retrain to account for those changes. So that is a very important and unheralded part of the predictive model business, is making sure that your models are continuing to perform. And what I should also point out here is that I talked about that we have 20 different models, and we are literally creating a prediction for each of those 20 models for each of the members who is eligible for that prediction. So that is a lot of predictions that are happening. They happen on a monthly basis. We, of course, store the most recent prediction for each of the models, but we've also started storing historical predictions so that we can look back at a member's history and see if their risk for a particular event is increasing or decreasing. So on this slide, what I'm trying to do is help you understand what it takes to actually build a predictive model. And this is an example put together by our machine learning team. So I really like the thought that they put into explaining the steps. And the first step is obviously a problem definition. So we can have we can get a problem definition from a member of our clinical team, or we get suggestions from clients. And in this example, we're talking about the need to develop a model that predicts the onset of chronic kidney disease. So this is an example of a classification problem where you want to predict that something is or is not going to happen. So it's kind of, you're predicting that something, a binary event. So the first step, once you have your problem definition, is to do a literature review. So we are surveying the literature, often with our clinical partners, and seeing what research says about what kind of characteristics might be predictive of the thing we are trying to predict. And in this example, age, gender, and frequent infections are some of the things that were found in the literature. And the third step is what we call exploratory data analysis. And so first, what we're doing here is making sure, first of all, that we have data about the things that were identified in the literature as being important predictors. And we're seeing if those features or predictors, if the trends that play out in our data sort of match what the research is showing. So first, you're sort of confirming that you have the data, and you're confirming that your data aligns with what you're seeing in the research, and you're gathering up all of the potential features that you might want to consider for inclusion in your predictive model. And then the second part of this step is what's called feature engineering. And a feature is a predictor, and what feature engineering is doing is taking raw data and transforming it into something that is both, in our sense, in our context, clinically meaningful, but more easily ingestible by the model. And I'll give you a very simple example of what feature engineering is. In the raw data, we always have somebody's date of birth, but for your model, you might want to have a variable that is age a year from now. And feature engineering is, in this case, would simply be the example of transforming somebody's date of birth to what their age would be a year from now. So again, it's really just transforming raw data into something that is both clinically meaningful and more useful for a model training purpose. So the fourth step is model training and testing. And I think this is what most people think of when they think of machine learning or predictive models. They're focused on the algorithms. And this is obviously a big part of it, but it's taken a lot of work to get to this point. And what we're doing here is exploring different modeling approaches, algorithms, machine learning techniques to see which ones produce the best results. And when we say best results, we're talking about accuracy, and measuring that accuracy is part of what we call the model testing phase. And so in this case, an accurate prediction of the onset of chronic kidney disease would be that our model says somebody was going to develop kidney disease when our data shows that in real life they actually did develop kidney disease. So that would be an example of a true positive. A false positive would be when our model says the member might develop chronic kidney disease, but their actual data shows that they did not. That would be a false positive. And on the other side of the fence, you have true negatives and false negatives. So a true negative being our model says this person won't develop chronic kidney disease, and then the member's history confirms that they did not develop it. So in these kind of classification problems, the measures of accuracy are always some combination of this idea of true positive, false positive, true negative, and false negative. And what we need to do is figure out how good would a model have to be useful to our clients. And that's it's a little bit of a qualitative discussion, talking with our clinical partners about how the results might be used. But in general, we set a threshold to say whether or not we accept it. And I'm going to stop at this point because while this slide makes this look like a very linear process, there's actually a lot more going on. And at any step of the process, we might realize that we need to take a step back, and perhaps we got the problem statement wrong, or maybe we need to look at more research papers to gather more possible predictors, or maybe our model results were not good enough to be useful to our clients. So we've got to rethink both the data that we're including and the modeling approach that we're including. So it's a very iterative, taking a step back process. And it's also something to point out is that there's a lot of, it's not just a technical challenge, right? There is a lot of domain knowledge here happening. So we are consulting constantly with our clinical team, and we have a lot of analytics expertise on staff, people who have a long history working with healthcare data and understand the limitations and what you can and can't do. So it's a technical challenge, it's a clinical challenge, and it's generally a domain expertise challenge. But once we have a model that we think we want to put into production, our machine learning team works with the analytics engine team to figure out how that's going to happen. So again, remember, these models are going to be run once a month, every month, and we've got to figure out the right way to display the data for our clients in the application. And again, once it's in production, we've talked about the book of business reprocessing. So we're taking that opportunity to make sure that the model is still working well, and that's our scheduled maintenance. But as with everything, we can sometimes have unscheduled maintenance. And you might have a situation where a client's processing failed because of one of the models that we put out, and we've got to do some investigation to figure out why that happened, prevent it from happening again for that client, and prevent it for the rest of the clients. So again, what I'd really like you to take away from this slide is, number one, that the process is iterative. Number two, that it's not just machine learning expertise that goes into developing this. We need clinical expertise and just healthcare data domain expertise. And third, that you're never done. You've always got to keep maintaining, keep monitoring, and sometimes tweaking the models. And so for my last slide, I just wanted to point out on the left-hand side, this is actually our inventory of current models. You can see some of the things that Raj and Tim alluded to, like predicting readmissions, predicting compliance with flu vaccine. But what we'd like to just call out here are two models, our predicted coronary artery disease and predicted CHF, congestive heart failure models. We use these models to estimate that for our book of business, early intervention. So again, we're predicting people who are likely to be diagnosed with these conditions in the next year. And our estimates for the book of business is that early intervention has the potential to save $1.4 billion in hospitalizations and ED visits. And our second insight is related to the prospective mammogram probability. And this is, again, a model that is predicting whether or not a woman is likely to be compliant with the screening recommendations issued by the U.S. Preventive Services Task Force. And this is we're at the end of Breast Cancer Awareness Month, and so it's kind of a shocking thing, I think, to see that our estimates are that more than half of commercially insured women in our book of business are unlikely to meet those guidelines. So we think that both of these types of models really provide actionable insights for employers in helping promote good health and reduce unnecessary costs. Thank you.
Thank you, Amy. That was great. And by the way, during Amy's section, I was able to respond to a number of questions. I didn't get to all of them. So again, we'll follow up and send the Q&A out to everyone after the presentation. So we're going to wrap up and bring it home with how to securely leverage data for AI applications. We're going to transition it back to Raj and discuss AI in the context of data security and producing responsible, ethical AI development.
Thanks, Tim. And we will get back to everyone in the chat. I know that there's several questions and Tim's been responding, but we'll make sure you get responses if we wanted to do so after this call. So data security and leveraging AI. A lot is happening now. It's happening at a rapid pace. I feel like every month you're seeing the capabilities enhanced, where now you have generative AI actually making actions on desktops. So it is uncharted territory, and I think organizations that push out AI that is untested, inadequate, biased is dangerous. So you do have to worry and make sure you're taking the appropriate steps and before you're launching these things. Poor or inadequate AI can have several negative consequences. From, most importantly, could be harming people. You could be damaging your reputation, and there are financial repercussions. So, personally, I take that very, very, heavily. So we would rather deploy things, particularly on the generative AI side, when, for our predictive models, the things that Amy alluded to, we can incorporate other new technologies like large language models in addition to the traditional machine learning, and we're testing results. As soon as you get into the generative AI space, you really want to make sure you test these things and you're comfortable with them so you don't have these adverse impacts. And the stakes, as we've mentioned multiple times, are a lot higher in healthcare. It's one thing in advertising to make a bad outreach for a marketing campaign. It's much different in healthcare, as you all know, and we really need to do this carefully. So I think there is an opportunity to take advantage of this innovation, but doing it in a way that is secure that you're comfortable with and that actually help improve care and results rather than create confusion, distrust, and harm to patients. So how do we do that? If you go to the next page, Tim,
There you go.
it really comes down to some of these guiding principles. So one thing we want to focus on at Cedar Gate is to make sure our AI or ML is interpretable. What does that mean? We test for model accuracy. We do all of the things that Amy just mentioned. We combine not only big data and these tools, but we combine it with clinical experts and people who actually know the business of healthcare. We also test that model accuracy. We test if it doesn't have to do with predictive models, it has to do with generating another result or enhancing human productivity. We're going to test it to make sure it's providing the right results before we interact with it. The other thing we're going to do in addition to testing is incorporating capabilities where when you have a result, you can drill into how the AI or how the ML model, what drove that decision. I know that's counterintuitive because you're relying on these technologies to take a lot of information to make a decision. So it's hard to trace how it actually made those decisions. But we do have capabilities with some of the tools we use to trace how it's making the decision, just to make sure the decisions aren't biased, that we're comfortable with how the decisions are made. And if you're audited, you can understand how it's made. So if you know the results and the accuracy of the predictions, and if you know how decisions are being made, you can feel more confident. And that's philosophical for our organization. We're also making sure that from a culture standpoint, from our team perspective, how we train everybody, all the new employees on the team that are onboarded into this group, as they work with these technologies, to know the risks that they pose, to know that we don't want any of these adverse outcomes, and to make sure that we, first and foremost, keep them aware that the insights we derive are not just insights. They're people. They are providers. They are folks like yourself making difficult decisions and making decisions on where to put capital and what partners to rely on. So we want to make sure that everybody on our team at Cedar Gate understands that and takes that seriously. And I think if you create that kind of culture, you can really take advantage of these tools, particularly in healthcare. And I'm excited about the opportunity they present for us and for all our partners going forward. So I thank you for listening in today. And obviously, if there's any other questions, we'd be happy to take them, and we will answer all of the ones in the chat. But really, it was a pleasure talking with you today. Tim, I don't know if you had anything else.
No, I'm trying to get to the chat questions. I was on a roll there for a little while, but I didn't get to all of them. We're almost at time. We'll give you guys a few minutes back. Thank you again so much for joining. We really appreciate your interest. We will follow up with all the answers to your questions collectively. And then if there's more that you want to learn about Cedar Gate, what we're doing, whether it's AI or any one of our solutions, we're happy to take those conversations offline and follow up with you. So again, thank you all for joining. Really appreciate it. Have a wonderful day. We'll give you a few minutes back. Thank you.